We'll get started here. You don't want that, trust me. All right, so thank you guys for coming. This is Protocol Me Maybe, How to Date SCADA and ICS. If this is not the talk you're supposed to see a flight attendant and I'll escort you out. Okay. I am Stephen Hilt. I'm an ICS security researcher and consultant at Digital Bond. I have roughly 10 years of security experience, around nine years specifically of ICS security experience. I used to work for a large utility in the southeast, where then I came to Digital Bond, started doing consulting and research. Recently I did the PLC pwn, which I talked about earlier in the year, embedding stuff in our cheap hardware inside of a PLC and to do remote code executions and stuff like that and send out commands, stop CPU commands via a text message. We're going to cover a couple terms in case nobody in here is familiar with these terms, such as ICS, an industrial control system. SCADA, supervisory control and data acquisition, and the DCS is a distributed control system. And if a lot of people interchange those and they're wrong, sometimes I am as well, so call me out on it, please. We're going to talk about a couple ICS protocols today. Here's a list of some of the most popular ones, such as Ethernet IP, Siemens S7, BACnet, Modbus, DNP, LawnWorks, OPC, and your suite of IEC protocols as well. Most of our ICS protocols, or as we like to say at Digital Bond, are insecure by design. You would expect them to have authentication, encryption, data integrity, and such. However, there is no authentication in most cases. There is no encryption in most cases, and data integrity mostly does not exist. So as an analogy to anybody who's not familiar with ICS, it's your unauthenticated VNC. Here's a good quote from Ralph Langer. The pros don't bother with vulnerabilities. They use features to compromise the ICS. And as you can see, that guy is totally a pro. He's got his ski mask on and his hood. So that's how all of us pros actually dress. Based off of that, what we set out to do at Digital Bond is we have a project called Project Redpoint. Project Redpoint is a Digital Bond research project that we use to enumerate ICS applications and devices. These tools are meant to discover and enumerate the devices via the native protocols. Then we take those and write in-map scripts via in-map scripting engine, and this is all while using the legitimate protocols of the ICS networks. To do this, there's a couple of methods we do this. We look at to see if there is already a pre-existing tool that is doing it, and then we can just convert it into an nmap to help. We will look at the applications themselves, if we own it or somebody we know owns the engineering workstations, configure the devices such as that, and we'll grab packet captures and do some analysis. Or sometimes we will actually just read the standard and reverse it based off the standard. And based off of that flow chart, we'll come out and we'll determine also if the script is safe enough to release for public use, because sometimes you get unexpected results based off of the way the queries work and such, that sometimes you still can crash devices. So if it does meet the needs and are safe enough to release, we'll release it. We actually have to date 3 nmap scripts inside of nmap that we wrote this year, and we'll talk about those here in a minute. As a disclaimer, Digital Bond does not recommend using the Redpoint scripts on devices that you do not own or do not have permission to scan. Even though they use the native protocols, there is still a chance that you can cause adverse effects. So don't be scanning the internet. With that, let's move on. To the Ethernet IP is the first one that we are going to talk about today. Ethernet IP is an industrial network protocol that combines the standard of Ethernet technologies and the common industrial protocol. This is a very popular protocol on the left, or on your left. You'll see a Allen Bradley Rockwell device, a WAGO in the center, and an Opto22 on the right. So this one is one that we actually took a pre-existing tool. I had to modify some code base. It's in Python to send a couple commands via the Ethernet IP. I found the interesting ones that I wanted to send, such as you can see in this packet capture, the command is list identity. And then once you send that to a device, you will get a response. I'm sorry, that's not. Okay, there. You get a response back. In that device, you can see that there is the EB&T card, which is the Ethernet card of a Rockwell device. Down at the bottom, there's also some other information in here that we'll cover in just 1 second. So the way that works is you literally send one packet to this device, unauthenticated, and it responds back with a bunch of information that you can use to list its information, such as the IP address that is configured on the Ethernet card. This may or may not be the IP address that you scanned if they are NATing or doing some form of routing to get to it. So in our nmap script, there's a couple different fields that we're going to pull out, one of which is the vendor. It's a 2-byte integer that we then look up. We got that vendor table out of the Wireshark dissector. So it's fairly accurate based off of what's there. The product name is that string you saw in the packet capture. Serial number is a 6-byte height, 6-byte hexadecimal numbers that's stored in Little Endian. And then the device type is a 2-byte integer that we also look up in a table that we pulled out of the Wireshark dissector. You also get the product code, revision number, and then the device IP address is the information we're pulling out of the packet. Here's an example of a device. It is a PanelView Plus, listed as a human-machine interface, which it is. PanelView Pluses tend to be Windows CE or Windows XP embedded. So that's kind of interesting to figure that one out just by pulling that information out of it. Its serial number. And then 192.168.50.211 is not the IP address that was scanned. So this one is behind a NAT or a firewall. You can actually today search these in Shodan. We helped incorporate it into Shodan. The search string is port:44818. Roughly 5,000 devices currently online in Shodan. What's that? It's at the bottom. It's port:44818. 44818 is the standard Ethernet IP and SIP port. Sorry, what? Correct. Yeah, with nmap you can decide which, you can change the port, so it's kind of hard to determine which way. 44818 is the standard Ethernet IP port. So then we decided, out of random information that I like to gather, how many of those devices were, the IP address was the scanned IP address. And surprisingly, it was 78% of the devices have a private address that are currently in Shodan. They're configured as that device IP. And then the most common one is a 192.168 address. Next, we're going to talk about the Siemens S7. Kind of the same information, a little difficult, more difficult because It relies on COTP and TKPT as well, so you have to negotiate those layers. It's not a single packet that you need to send. And what you see there is the hardware information. This one specifically is it looks like I don't know what that device is necessarily, but if I remember right, it's actually a Windows Simatic machine. And this is another packet. So per information you want to pull, there's different levels of packets. This is another one we pulled out of the SCADA Strangelove. They have the PLC scan, which scans for Modbus and as well as S7. We worked to incorporate this one into Nmap because there's already a Modbus scanner Nmap script that already pre-exists. So we decided to implement this one by reversing the Python code, grabbing packet capture, seeing how they were parsing the information out. That way we can build a table and store it and output it into an Nmap format. So the information that you can pull based off our script that we released is the module information, basic hardware, the version, system name, model type, and serial number. The interesting ones are the plant identification ones, fairly interesting. That's actually a string that's entered by a technician about a physical location, usually of where the PLC is located. And then the copyright information. It's usually original Siemens equipment if it is a Siemens device. So here's an interesting one I found online. It says it's a Siemens Simatic S7 200. Plant identification field's filled out. It says Mauser factory. And then the system name's fairly interesting as well. So you look at that and you go, oh, the Mauser factory, that's pretty sweet. Or is it the Mauser factory? But something's not making sense because it says Technodrome. I don't know if anybody's familiar with the Technodrome. That doesn't even make sense. You can't have two villains with each other. This just doesn't even make sense. So it's actually... So after doing some searching online, you find out that that's actually a conpot. So here's the conpot. At the bottom is their GitHub. And then the configuration for those fields are right there. And you can pull off to the right. It's the Mauser Factor, Technodrome, and the Siemens Simatic S7 200. The interesting one is the Siemens, Simatic, S7 200. There's actually no fields out in the wild that actually have commas in them, usually for that system description. So that's like, go back to the original point of the talk, protocol me maybe. You want to go date this device. That's like you're talking to a hot girl. She's like, call me. And then you're all like... so the number of, once again, random facts. Again, I like random facts. After pulling all the information down from Shodan and searching for those exact conpots in that exact same configuration. There may be more, there may be less. But right as of now, there's 95 devices that I can identify as conpots. Some interesting ones that are out there online, using the plant identification field. The one on the right is a sawmill overseas, and then the best I can identify, the other one is a paper facility, newspaper print, so a PLC on one of their printing lines. This one was very interesting. You got to use some Google Translate every now and then when you're looking at Siemens devices because they're usually most popular overseas. The engine room and police. That seems pretty interesting. But that other word, couldn't figure that one out, so did a little bit of Googling on that one. Turns out it's a cheese and dairy manufacturer in Czechoslovakia. So it's on Police Road. Sometimes you don't even need the plant identification to field to be filled out to actually start figuring out what the device is. The system name is a technician entered field. So this is water plant 1, water plant 2. And based off the IP addresses of these, you can actually figure out what they are and who they belong to. So this one's currently in Shodan as well. Port :102 is your search string. Currently roughly around 4,000 devices online on the internet in Shodan. Next one we're going to dive into a little bit is one that we've been working a lot recently is building automation control networks, or BACnet. BACnet is a protocol designed for building automation. So this runs lighting, HVAC, there's power meters, a bunch of stuff in buildings for automation of the building. This is one of the ones that we just had the standard, so we can reverse it based off the table that's actually pulled from the standard is all the properties of the device object type. So there's actually information, all that's information you can query. So we went through that and decided which ones we found the most interesting to pull, but you can pull all that if the device supports it. So what we did was there's a really cool open BACnet stack on SourceForge, and it runs really well on a Raspberry Pi. So we got that, we did that, and put it together, built the system, and started just playing with it to see what kind of information we could query out of the device and see if it really supported and that our packets were formatted correctly. You can also use, on the bottom right-hand corner, is a screenshot of a BACnet browser. BACnet allows you, it's a tree-based, most of the browsers pull the objects into tree format. So you can see in the packet capture there, read properties, like 17, 8, and 18, object name, and object list. So that shows that the information based off the table that we saw in the standard, and then using Wireshark, once again, people are very awesome and write really well dissectors already for you most of the time. So it helps you doing a lot of this work about which fields are what and then how to also interpret them. So based off of that table, the object name was, according to table 77, which in hex is 4D, that's the string we sent based off of the packet capture from the BACnet browser. And as you can see, the last 2 bytes are 4D. So the next interesting ones we probably want to pull are the vendor ID, which was 120, description, firmware, application software, model name, location, and the most important one is the object identifier in BACnet that actually allows you to talk to it further once you know that information. So this is us pulling out of the BACnet, open BACnet stack, all those properties that I just listed. And showing you that it is possible, and this is a UDP-based protocol, and you can pull all this information and you get responses on properly formatted packets, so you can really identify a good UDP-based protocol here. So based off all that information that we gathered there, we went and wrote an nmap script after several iterations of a Python script to pull vendor ID, object identifier, which is the number, as I stated earlier, it's a number that uniquely identifies that device. If the object identifier is known, it is possible to send commands with BACnet client software, which is important. Take note of that one. You can go to the firmware, application software, object name, model name, description, location. Location is usually a user-defined string. Recently we added 2 different fields to the script. This is one of the first ones we released, which is the broadcast distribution table, or BDT, and the foreign device table. The broadcast distribution table is the list of BACnet devices in the BACnet network. This field needs to match each and every device that this device is talking to, that if it's listed in the BDT, each one will match each other. The foreign device is a list of foreign devices registered within BACnet. They're two different tables, and you don't have the same addresses in it usually. So here's, once you do the BDT, you can then pull information out about the devices it's communicating to. So here's an interesting one I found online, Prison, fairly interesting object name. So then what you can do is then start mapping out all their connections to find out more about the device, what it is, what does it do. So here's the device and the three existing ones that match the ones that are in the broadcast distribution table. One is object's name's NAE55-1, which matches the model name, elevated tank, and old plant. So they don't seem really to match each other, and the prison may just be a one-off kind of oddness. So then what you can do is then view the connected inputs. So they're usually a serial-based connections or behind the routers themselves. And you can start pulling information. This one, I connected to it and pulled the information down from it, and you can see it says into trunk. Into is actually another protocol, so this is actually a trunk back to another serial-based protocol. Prison.day level. And then based off a location, I started looking at it, and it turns out these are actually 4 water towers in the area around the prison. It's kind of a minimum security prison. So now that we can pull the broadcast distribution table and the foreign device table as well, let's figure out what more information we can actually gather. So system requires you to join the BACnet network and register as a foreign device to enumerate the devices that are attached to it. So once you're registered in the FDT, you perform a whois, much like ARP, and then the devices actually start responding with IAMs. So here's an interesting one. It's a campus police building. So what we're going to try to do is try to pull more information. Now, I would like to point out down at the bottom on the broadcast distribution table and the foreign device table, we actually got NACs, not acknowledgements, from the devices. So you send it a BVLC join request, and then I wrote a special script to test whether I can actually join it or not, because if BACnet's very good about telling you if you can't do something. So actually on that one, I can't actually join the router. So once you can't, and that's the response of the NAC, as you can see, it says register foreign device NAC. So once there's not much you can do to this device anymore, because somebody has configured it to not allow foreign devices to register. So it's kind of like you can actually prevent, and they do have a little bit of security inside of BACnet, and that's about it. But once you do perform a successful whois, as you can see, you can get a bunch of responses from all the devices. You'll see IAM device 1503, IAM device 1202, so on and so forth. So you're getting a lot of information about how many devices are actually connected to this device, and you can start parsing out that information as well. Sometimes you'll get devices like this where I solely found this one interesting based off of its location. It's actually in the town that I live in. As you see, the broadcast distribution table has a 192, 168, 125, 82. So you kind of can figure out what their BACnet network looks like based off of that information. And also, there's a device joined as a foreign device. Foreign devices do have timeouts and time to lives as well. So you can join it with a really short time to live, and it'll delete itself, usually. Sometimes you're in there forever, and it keeps giving you information about the device forever. So that's one of those, as you can see here, the script on your left is a script that we wrote. Because some devices never delete you out of their table, based off our testing, that's one we don't release, but you can do the same based information in a BACnet browser. The interesting information is, as you could see before, there wasn't anything overly descriptive, but once you join the device and start pulling down its objects, you can see that it's called Liberty Tower, Liberty Chiller, VAVHU, 15, 10, 3. It goes up to 17. It's a 17-story building. And those are most of its VAV. So then you can pull information, like over on the left, you can pull what temperature it is in the building currently at this one. So the VAVHUs, those are the air handling units, usually the VAV boxes. The space temperature is going to be that sensor on the side of the wall, like back in the room. Pulling that information, it was currently 71 degrees when I pulled that information out. You can go and pull more information even down to like power monitor spelled wrong. The point of that one, I pulled that one because I thought it was interesting, showing you that human people, the technicians are actually entering these. They tend to be very, very descriptive, even if they are spelled wrong. And I'm not a good speller, so I can't really fault him for that one, or him or her. You can also see on the right, there is another one. It says it's the VAV elevator lobby. So that's actually the temperature in the elevator. So now what do? We can pull information out of the device. We can figure out what values are currently set. So BACnet actually supports nice writes. So you can actually determine whether they actually support that the right property. Because you can do a query for supported protocols, and it'll respond which protocols it actually supports. This one's with supporting writes. And you can see that in the browser that I was using, there is the write button, so you change the 0 in that field to 1, 1000, whatever. Sorry, we're not actually going to demo me changing those. So as I said, I found this one solely based off of location. The location is in the town that I live. There was a tower called Liberty Tower. It's a fairly new one. It is 17 stories tall. So kind of interesting. You can map all that stuff out. And that's actually a picture of the Liberty Tower. And that's Chris standing up on the tower because he uses me in his pictures on me on a castle. Other buildings, my coworker Reed, and Chris really loves squirrels. So since he always picks fun at me and puts me in pictures, decided I'd put him in one today. So big interesting thing is, so you take that building there, and if I walk through a air handling unit, an HVAC system, but lighting control systems are in BACnet, and you can find them. So you can actually change. This is actually something you could do. So once again, this was one of the first scripts we released. We worked with John Matherly at Shodan, a great friend of mine, and we had him help scan the internet for him. If you search port 47808, you'll find roughly 15,000, 10,000 of which are in the U.S. BACnet, so you're going to find HVACs, lighting. Some people do create level temperature, fire suppression systems. Sometimes I think you can even find physical security systems are running BACnet as well. So you can see other devices. So we perform what's known as an ADPU query originally to find out if the device supports it, but it'll also positively identify the device as BACnet because it will send an error. As I said earlier, it's very chatty about whether you can or can't do something. So you'll actually see ones that are just errors. We actually wrote, and I don't know if it actually made it in, but a service probe for BACnet that we put I submitted to Nmap as well. So you can just run a quick version probe scan with a -SV on that port, and if you didn't want to pull all the information but wanted to positively identify a device as BACnet, And then you could search those and query those furthermore as they returned. So lastly, we're going to talk about Modicon. Modicon is a Schneider product. Schneider bought the company. Modicon was one of the first PLCs. We'll go through this one fairly quickly, just kind of because same information, same basis. These things are insecure. You can query them. You can do a bunch of fun stuff like that all the time. Modicons use Modbus. So here's me performing a read identification via function code 43 to a Schneider device. As you can see, there's Schneider Electric SAS 140. It's an NOE card. This is actually one that Digital Bond owns, and we own the Unity Pro software to configure it. So this is packet captures that we did based off our own equipment. Switch over to Modicon uses a proprietary function code for most of its communications via function code 90. It's not documented, that we can find without paying money. Schneider doesn't, it's not something you foresee without talking to Schneider a bunch about getting it. So luckily it's all in clear text, so you can kind of figure it out. As you can see there, it says CPU 311.10. So inside of the Unity Pro, you can see the second slot on that chassis is a CPU 311.10. So that positively identifies the information. Other information that I found fairly interesting when I was pulling information out of it, which is the screenshot there that is transferring the project from the PLC to the computer locally. And you see the project name, the version number, and the last modified date. So we were looking for this information based off that, and that's the way I was working this one. Is I'd click around in it, gather a packet capture, find interesting things displayed on the screen, and then go try to find that information inside of the packets. And here is actually the one that has the date timestamp, the version number, and the project name. Let me skip through the transitions there. So the version is currently at that time, it was 008, which is stored in Little Endian there at the bottom. The project name is highlighted as well. And then the date timestamp is actually fairly interesting. It's also in Little Endian. 07DE is 2014. 01, it was January when it was last configured. So you start looking through that, and you go, what kind of date? It took me a long time to find that, because who honestly stores a date timestamp that way? It's not usually the normal way, so it actually took me a while to find that one. So based off of that, what other information can we pull? So looking through the packet capture, I found a very interesting packet on a device online, actually, because mine didn't support this one. But it was, you can see the project. There's a version 6.0, another string, and then some D:. Well, these don't run Windows, so what is that exactly? It turns out, based off the extension, which is STU, which is the Unity Pro project, if you save the project locally to your machine. And that's the file stored on a machine. And the actual workstation name is in that packet as well. So based off of that, the information you can pull is vendor name, network module, CP module, firmware. The memory card is actually interesting. It's the model number of the memory card that's plugged into the CPU module. It's not interesting except for possibly asset inventory. Project information such as I said, workstation name, and then the location where it was stored, project revision, project last modified date. Here's an example of one online. As you can see, I pulled the project last modified date, and I started thinking about that. And I was talking to my coworker, Reed, and he's like, I wonder, what's the most popular day of the week to make PLC changes? And then I asked, what month? So it was Tuesdays in July. Kind of interesting information. You could probably extrapolate more information out of that if you started breaking it down by sector and then refining your searches based off of IP address ranges and stuff like that to figure out when those specific sectors are making changes. So as I said earlier, you could pull the project information. So here's some screenshots of some interesting ones. On the top, kind of interesting, they're storing it on a file share. The middle one's good because it says Gradic PC and the user's name is Gradic. And then the bottom one I find the most interesting, that it's a share on a VMware host that then somebody's storing it in Dropbox. So then with this information, you start thinking about how do you figure out where these devices are, and can you start doing like a blended cyber physical attack? So here's an example of one. It's the PC says Patriot Tech PC. It based off a search is an integrator. Username Chris Alt, who is storing it as Dropbox as well. Blurred out some information based off of the actual location, but you'll see Mendel, Energy, PLC, last modified date, and that stuff. So based off a quick search of some of that stuff I blurred out, here's a bigger blurred out page with some information. It turns out it's the Mendel facility, as you can see there. It's a gathering station. This is an oil and gas facility in Texas. As of this morning, we put it online. This is a brand new one we're going to release. So it's released as today. So it's on our GitHub, or Digital Bond GitHub. So download it, have fun. Don't scan the internet, scan your own Modicons. So with that information, and we have all that information gathered, where do we go from here? Most of them have web pages that you can poke around on, gather more information. Pre-existing Metasploit modules, most of these that Digital Bond wrote. So this one will stop the CPU on the the Rockwell devices. So this is using Ethernet IP and SIP. Exists. This one is the Siemens stop CPU command for an S7 that Dylan released a couple of years ago. Based off of some other information, screenshots, that's Unity Pro on the left. You can see the stop button. You record that packet, you replay that packet, it stops it. Those actually exist as Metasploit modules today as well. Ethernet IP has, we have a copy of Ethernet IP standard. You'll find interesting ones in there, such as restore back to factory default. More descriptions about restoring it back to factory default. Then here is a couple links that we have to our official repository. Then we have Ethernet IP. Those are the committed ones to Nmap. They're slightly different than our main ones because they've been formatted better for Nmap. Because Lua is a fun language to program in. I'm not a Lua expert, but the people over at Midnet and even Ron up front up here, he's a lot people better than me at Lua. So then we have some of the code that we took and originally used, such as the Modbus and S7 stuff that the PLC scan that SCADA Strangelove did and released a couple years ago. They have a couple other protocols that you can use. I believe they have an IEC, the Profibus one. Haven't really looked and played around with that one yet, but that's on the works for us to we're going to convert that one, or actually they already had an Nmap script for it. They haven't committed it, so we're going to look at it and help them try to commit it into Nmap itself. And then the Ethernet IP script that I mentioned earlier that I was slightly modified to get to work in the way I want it to work is PyENIP. You can search GitHub for that one as well. Now I'm apparently gone super fast, so here's my thanks slide. Title of my talk actually came from Senakpan. Reed helped me a bunch, Killian from GitHub. And Bonsai Viking, he's the one who did most of my help. I harass him, Daniel, all the time for Lua help. People at InMap Project are awesome and support you at all time, just answer your questions all the time. And Jeff is not actually an ICS person. Jeff is the one who helped us a lot recently on the BACnet stuff. He's a building automation guy who took some interest in what we were doing, found the stuff on Shodan, and then reached out to us and helped us add the BACnet distribution table and foreign device table pulls. So that was very interesting. We also look for anybody else who wants to help and incorporate another protocol, any protocols that they have, so on and so forth. So at this point in time, if anyone has any questions. So once you query the device, as an attacker, you can pull information, and then you can start changing set points. Much like even within Stuxnet, you could start changing the ladder logic slightly for variations. Yes, you can turn on and off. Yes, all without authentication. The freeware that you're mentioning is, I think it's called AB Ethernet. It's a Windows utility, and it specifically mostly works with the SIP devices that relied more heavily on SIP than Ethernet IP. It talks to Slick 05s and stuff like that a lot, but it doesn't talk to Allen Bradley's too well, or to the Rockwell Control Logic family. I think it works on micrologic still and stuff like that. Yeah, there's several. There are several free ones out there. People are working, even with DNP3. Chris and Adam Crane work great with the Open DNP3 stack. So there's a move to people getting the more freeware and open source projects into the ICS space, which is helping actually push these things to possibly be more secure in the future. So we have several talks, and a couple years ago, these devices are online. We recommend that they never be online. A lot of customers will do some searches for them, so on and so forth. But with those numbers that are out there, and a lot of them are in foreign countries and such, it's hard to coordinate some of that stuff. But they are online. Yes. Can you go sorry. Yeah, you'll actually see an uptake since we started scanning for them. But yeah, you can actually look, and inside of the control system space, there's people who monitor this stuff. We tend to coordinate with US CERT and ICS CERT after we do some of this stuff. We get Matherly works with them very well to notify them and then tell them when the results are done as well. So they'll go out and help alert people as well. What was that? Yeah, so we actually coordinated with Japan CERT because we found a bunch of BACnet devices in Japan on the recent searches that they're not coming up. So in Japan, they've taken BACnet off the internet. What's that? So a lot of various sectors, a lot of people, a lot of them are in oil and gas, and they're out on pipelines and such like that. for a lot of what you see, or they're just remote. And a lot of people just use PLCs that aren't critical. They're just doing a simple function. Yeah, or it could be a food plant. It could be, the one I found in Czechoslovakia was a dairy farm. I mean, so it's all about what criticality it is, and you can chase these down till the cows come home. Or but there's a lot of coordination, and we try to work with representative countries and alert them when we're starting to do stuff and of our results when they're out there. That's one of the reasons why we personally, I don't have the infrastructure to scan the internet, nor do I. That's John Matherly's awesome. He does, and a lot of people are already going to Shodan to search for devices. It's yes and no. We want to see them off the internet. We don't even want to see these on corporate network. That's one of the reasons why we release these scripts, is so that asset owners can scan their corporate networks and find devices that are on the corporate network. These things need to be, they're insecure. You can write to them. They don't need to be anywhere that mass people can figure out what to do with them. Yes. So you can restrict it to devices that you want to know about, or you can just block it altogether, based off of what I've seen. Now, some vendors may have implemented this differently. So that the NAC itself it's telling you that you can't do that function. It told you, no, you can't join me. As I said, it's very chatty, and will tell you when you can't do something. Any other questions? Yep. The numbers are changing. The hard part is figuring it. A lot of it's hard to figure out who it is, mostly because they're going to be the majority of the numbers. And Chris brought this up. I think it is B-Sides Augusta talk, which is the majority of you're going to look at. They're on Verizon, AT&T, overseas on mobile networks. They're moving around. Their IP addresses are changing. It's the same device somewhere else now. So, I mean, the numbers are kind of hard to figure out where they're moving at when they're on cellular networks. Mm-hmm. Yes, correct. So there's a lot of testing, as we recommend, once again, not scanning the internet. So there is an inherent risk to doing that, but without identifying it, you won't know it's there. Somebody else will. And you know, even to the point where the latest malware, Havocs that attack are specifically targeted ICS, you'll notice that they were using actually some of these protocols. They were searching for Ethernet IP, Siemens, I think they were doing Modbus. I saw one report as well. And then OPC. So there's the bad people are already out there searching for it. Any other questions? All right, if no questions.